Hey, hello. Hi. My name. Okay. Sure. My name is Věroš Kaplan, and I would like to talk about Kubernetes on a single node. Well, is there anybody who doesn't speak Czech or Slovak, or should I switch? Great. Okay. So let's continue in English. No problem. Well. Okay. So about me. I am Věroš. At the moment I'm freelance server administrator, applications administrator. I'm working with servers for 20 years. I started in the last century. And what we are doing in our company or with my colleagues, we are deploying and running applications for our clients. Typical use case or typical customer says, well, we have an application and we would like to run it, or we have server and we would like to run it. And that's my daily job. And I would like to talk about this. On the beginning, I would like to confess, sometimes I'm running Kubernetes clusters, so-called Kubernetes clusters with just one node. So shame on me. Okay, and why I'm doing this heresy. So, and why I do it, and I would like to present why I am doing that and what I have learned through the time. So, and warning: don't try this at home unless you have a reason to do that. Okay, so as you probably know, Kubernetes has some components. Let's see. It has some control plane. It can run on some nodes. You can use cluster API, cloud provider API, or not in current Kubernetes. And it has a lot of components, lot of moving parts, and so on. And typically, this setup is run on a multi-node cluster, multi-node setups, and sometimes and I would like to show why I am running this on just one node. So, while we are running some clusters for our customers on a large infrastructure on multiple nodes, sometimes we have a customer who calls us and he says, well, we have a server and we have a PHP application. We don't know how to install it and we would like to run this application on the server. In the past, we usually used Ansible. Asked Ansible, please set up a LAMP server there, and it works. And upload the application. But after some time, some weeks later, the customer calls, well, the application needs some dependencies, for example, non-standard PHP module. Or the applications need a special server, for example, map server. Please don't have anybody tried to run University of Minnesota map server? And I'm sorry to hear that. Please. Okay. Well, my degree is from cartography, so I should know that I can do that, but I don't like it. Please don't try to run a map server. Don't try to compile it and so on. It is much easier to take the map server and run it in the container. You will just put the beast in the container, deploy the container, and it runs. But when the customer didn't say in the beginning, we are going to run the map server, you don't know about it. So after some time, we found, well, we should deploy even the most simple PHP applications into container. It's easier. We can prepare complete running environment. We can add dependencies, and it's easier. So we should use container. Okay. At the moment, we can still run with Docker, Podman, or whatever. But later, the same customer calls. So, well, we have server, we have Python application, and we can put it into container. We can store the application in container. We can deploy the container on the machine, and it works. And then customer says, well, and we have production environment, and we don't have money for separate servers, and we would like to run staging and two testing environments on the one server. Okay, we have containers, so we just deploy another containers with the same or similar image. We run it, and then we found, well, we don't have load balancer at the moment, so we have to invent some load balancer for Nginx, Apache, whatever. And then we found, well, we don't have TLS certificates. We should add it too. And at this moment we found, well, and there is a really nice ingress controller in Kubernetes. Why we just don't use that? And there is a really nice certificate manager called Cert Manager. You probably know it. And why you just don't use that? And at this moment we found, well, probably we should run the Kubernetes on single node. Yes. Another use case is customer asks, we have just one simple PHP application. And okay, we deploy that, and a few weeks later, and we need to run Node. Which version? I don't know. So probably multiple node applications with multiple node versions. Oh no. So again, this means we should probably start in containers, and then it is from the last month we have found that a customer has a really ancient PHP application with PHP 5.2. And using container, we can just start run it and deploy it, and it's easy. Some other parts which leads to leads to containers is for example CI. While you can use GitLab CIs to deploy some pure Docker containers or pure OCI containers and patch some Docker Compose or something like that, it's much easier to use GitOps, something like Argo CD. For example, for deployment or for testing environment, we usually would like to use some single sign-on. For example, OAuth proxy or something like that. And then when we have finally running applications, customers asks, well, we have an application, but our developers needs to see the logs of the application. And while I can explain developers, well, just log in here, and in some obscure directory there are logs of your applications. It's much easier just to use standard Kubernetes tooling and I can say, well, go there, use kubectl logs and see the logs, or you can, for example, use K9S and look there, or even better, you can use Argo CD and see the logs there. So this is our motivation. Did anybody try to deploy, for example, Docker containers or simple containers on machine in the last year? And how it felt after a few months? Great. Okay. Few people tried, and one people seems to be happy about that. Great. So, and probably you know the law of the hammer. When you have the hammer, everything in the world looks like a nail. It has a page on Wikipedia. So, and because we are using Kubernetes at some bigger customers, we just realized it can be easy just to deploy Kubernetes. So our mission just moved from just take this one application or this application mess or mesh, and our mission just moved to just running applications in container. We would like to try it with as low overhead as possible, because the memory isn't so cheap, or CPU. We would like to provide basic observability. We would like to reduce the deployment inconvenience. The CI/CD part can be hard sometimes. With Kubernetes, it's easier for us. And we would like to reduce operational inconvenience like certificates and load balancers and so on. So for us, we just tried to use Kubernetes. It worked for us. And some lessons learned about that. At the beginning, we tried to use K3s. It's a really small Kubernetes distribution. It's targeted to the the small devices for edge computing. Probably everybody heard about that. For people who didn't heard about that, it's a simple Kubernetes distribution. It doesn't use etcd as storage. It just used something called I forgot the name. Sorry, Kine. I saw, and it stores the data about Kubernetes in SQLite. So you just omit the etcd, which can be memory and CPU hungry. You just replace it with etcd, and it's nice because it's relatively low. It has a low memory requirements, the K3s. It's really easy for backing up because it can back up. You just back up the the SQLite file, and you are done. If you don't like the K3s, which is very small, we are using Rancher Kubernetes engine number 2. We had some issues with K3s because in the terms of observability, it was hard to debug, for example, issues with scheduler and so on, because K3s runs as just one binary. It's one binary. It's one process, and API server, scheduler, controller manager, everything runs just in one binary. Kubelet is run there too, and when you need to check logs of the API server or when you need to investigate logs of scheduler, you will just take the log of K3s and take out just the parts you need. It was ugly. So for some larger customers, we moved, not so large, but still on one machine, we just moved to Rancher Kubernetes engine. It's still one binary. It still contains all the parts, but it runs it just runs Kubelet. It just runs its own server, and you can investigate the API server, control manager, and other parts separately. By the way, Rancher Kubernetes engine also uses etcd, so it can be easily scaled to more than one machine. If you need, for example, high available control plane. The disadvantage of one machine with K3s and Rancher Kubernetes engine is that it's not so easy to be, or not so smooth to be upgraded. While the upgrade is just changing one binary, you will have to restart it, and it can lead to can produce some small or short downtimes. But well, when you run just one machine, you usually count with the downtimes. So the really nice parts with the Rancher Kubernetes engine and the K3s is that the installation is really straightforward. You just download one binary, you prepare some config files, you provide system unit just to start it on the machine start. You provide kubeconfig, provide kubecontrol binary because you would like to communicate with to communicate with the server, and you are done. So these are 5 simple steps. And of course, as we are using Ansible, you can use, for example, some Ansible role just to deploy that. Please don't try to use that role at home. It works for us, for our customers, and there are probably rough edges. But feel free to use, send patches, and so on. It's up to you. So the deployment of Rancher Kubernetes engine for our customers means just using Ansible. We just set up networking, set up Ansible role, and we are done. So then, now we have running Kubernetes cluster. I would like then to deploy the nice Kubernetes parts, for example, ingress controller. The good part is that ingress controller is already present in Rancher Kubernetes engine, so you don't have to add it there. But if you need to add some parts, you can still do that. Both Rancher Kubernetes engine and K3s, it has a magic directory called server manifests. When you put some YAML files there, some Kubernetes manifests, it will deploy them to cluster. And what is really nice, both these Kubernetes distributions contains Helm controller, and when I need to deploy some Helm chart, I will just create an object called Helm chart. And this is example of deploying OAuth 2 proxy. And I say, well, please install this Helm chart from this repo. We have some settings here, the values, and it's there. So again, for deploying, for example, the OAuth 2 proxy, it means I just use Ansible, deploy this one file, for example, by template, to directory, and it works, magic. So the bad thing, it's still a lot of YAMLs. So I don't like the idea of YAML. I don't like the idea of YAML generated by templates, but it still works. But yes, I think yesterday we had some issues with YAML indentation. Great. Basic Kubernetes add-ons. We are using the basic Ingress Nginx, because in Rancher Kubernetes engine 2 it's already present. You just deploy that. You can is deployed by Helm chart. Magically by the distribution. You can customize it by some special objects called Helm chart values or something like that. It's in documentation. And what's nice, the Ingress Nginx can handle TCP endpoints too. We have some customers who runs their special TCP applications, not only HTTP, and you can even handle it with Nginx. And another part we are using a lot is Certificate Manager. You probably know it. And we just create. We just create certificate object, and Certificate Manager takes care of deploying and of creating, and obtaining, and deploying the certificate for us. So no more issues with Cerbot, no more issues with ECMA DNS, and so on. So these are the basic add-ons we are using. So here is an example when we need to change configuration of the Nginx. It's possible. There is a Helm controller in both of the distributions, and you just create this small file. Small manifest file, put it into the manifest directory, and Rancher Kubernetes engine takes care of deploying that into API server, which is really neat for me. I can manage this by Ansible. Good for me. So, not so basic add-ons we are using. I really like the SOPs operator. It's an operator for both of these plugins or add-ons are for managing secrets. Not all customers has their own secrets management solution. So SOPs is a solution which allows you to store your secrets encrypted in Git repository. You create SOPs object in the Kubernetes, and SOPs operator just de-encrypts, just creates a plain version of the secrets. It can be, SOPs operator can be imagined as a poor man's vault. So we are using this. And if you are a happy one and you have Vault or some AWS secrets and so on, it's much better, much more comfortable to use external secrets operator. Both of these add-ons can be deployed by using Helm. So again, we just create Helm chart object, custom resource. By custom resource definition, we just put it into Kubernetes, into disk of the master server, and we are done. Okay, how to deploy applications? Now we have only Kubernetes running, no applications. If you are on the simple side, or if you don't want to do some more complicated, for example, for some very long time running applications, you can just put YAML file into server manifest. It's there. We have some applications at customers which they deployed a few times a year. Server manifests are good enough. Or better, probably you can use Argo CD, which means that the deployment of the applications can be done by Git operations. So you probably know Argo CD is just magic piece of software which takes Kubernetes manifests from Git, GitLab, GitHub, and put it into Kubernetes. So this is an example of the single node Kubernetes server or single node Kubernetes cluster. It's an application which was running in production environment, development, and the beta stage. This was still proof of concept. It didn't run at production. The project was cancelled last month, unfortunately, but it worked. And there are some other parts like Minio, which we used for S3 storage, and we used Argo CD Bootstrap, the application of applications design pattern, which is recommended by Argo CD. So the nice part on Argo CD for us and for our customers or their developers is that you can easily check, is the application already deployed, because Argo CD provides you some basic observability about state of the deployments and pods. And another nice part is that the developers can reach the application's containers, and they can interact with application by terminal, and then they can check the logs. This was for the selling point for me and for them too. And when we provide some simple sign-on the Argo CD, we don't have to set up anything. It's pretty easy. So, well, with Kubernetes or with applications, you probably run on some storage, with some storage. We found that while you can use host path in Kubernetes in deployments, it works, but it's very error prone. Because when you use host path and you say, well, the test application is using /data/production as its, or production application use /data/production as its storage, as host path, it works. But when you do copy and paste, and probably we do copy and paste, sorry, and it lets that two applications can overwrite its data. So don't do this unless you have to. The much better is using PVC, persistent volume claims. In K3S, there is a local path provisioner. You just say I would like to have PVC for data, and the local path provisioner just creates the directory on a local disk and provides it to the application. Unfortunately, you can't use local path provisioner when you would like to expand to more than one machine or one node. You can use NFS provisioner, which is pretty easy. Setting up NFS server is just one Ansible role, which we already have. So you can use NFS provisioner, the old and legacy, and it still works. or you can use some ZFS provisioner when you have ZFS. The nice part on ZFS provisioners is that it can enforce quotas, the resource limits on storage. So it depends on the customer. It depends on the money that the customer can spend. Whether they want it to have it good or cheap or something in the middle. Great. Logs collection. How can we do that? It depends. We can use FileBeat. Some customers are happy with FluentBit storing data into S3 buckets. You can use Loki. We are currently investigating Grafana Alloy because it looks really nice to us. It depends. Metrics collections, again, you can use standard Kubernetes, standard Kubernetes tools, Prometheus, Victoria Metrics, Grafana Agent or Alloy, sorry, and so on. Okay. What is really nice on the upgrades, control plane updates on these two distributions, you just replace the binary and you are done. When you need, for example, to upgrade some applications, we are running for our customer, for example, Uptime Kuma. It's a simple monitoring solution, and you would like to keep it updated. You can use Renovate Bot, and Renovate Bot then says or notifies us, well, there is a new Uptime Kuma version. Do you want to upgrade it? And I say yes, or it creates a merge request for us, and I just deploy that. Well. The advantages of this simple node Kubernetes is that it's distribution agnostic. Last month, I have found that some of the enterprise customers are using, or so-called enterprise customers are using, Gentoo Linux. I was quite surprised, but says, well, no problem. We just put Kubernetes there. We are done. The Gentoo part is their problem, not our. Great. Another advantage is that we are using containers, and compared to simple Linux node, it is easily extendable. It's good for me because it saves us a lot of work. We can easily add some more nodes, and it's a standard tool for us. We are running Kubernetes in a large, so we can run Kubernetes in a little small clusters. And the best part for me, the GitOps approach is possible. When I ask colleague, please upgrade this version, he just upgrades the version in GitOps, in Git repository, and we are done. We have audit trail, we know who, when, and probably why did that. Great for me. And disadvantages it has. Initial setup is more complicated compared to plain Linux node. Well, Ansible does it for me. It's someone else's problem. It has some small CPU and memory overhead, but for me, it's much better, or from my point of view, it's better for me that computer has some memory and CPU overhead than to my memory, because my memory is really bad. So it's the computer's problem, no problem. And Kubernetes, well, it can be sometimes hard to debug, because when you need to debug application in Kubernetes, it can be a slightly more complicated. But, well, lessons learned. It works for us, but Ansible allows us to start faster, the management is more extensible, and we have Kubernetes, which is great. So current deployments, we have some hosting servers, we have some Drupal deployments for our customers. So all the parts I pointed out at the beginning, we are running that. So, as you see, Kubernetes is a simple Lego. You can use that. You can build small or large things. You can easily step out on the Lego. But when you use it in a clever way, it can save your time. And I hope that it saves our time. Well. And that's end of the file, and it's probably time for questions. Is there? What should I do now? 5 minutes, right. Oh, see. Question, do you think about to use K1S? Well, I don't know K1S yet. There is a much more Kubernetes distributions that I can read about. So I have never tried that. I don't know about that. Well, you mentioned some clients needs updates only a few times a year. How are the servers? Do they work? Regular maintenance, read it. How do you monitor? Okay. What's the question? How are the servers? Do they work flawlessly? Yes, they usually work. The servers are usually sometimes else problem, probably their infrastructure team, not our. Some regular maintenance. We have some monitoring. Probably no. You can run some updates there, but it works usually. And how we monitor the VMs, it depends. It depends whether the client wants us to monitor them. We are using Itzinga, we are using Prometheus. It depends. So. And which tools do we use to oversee such fleet of small clusters? Again, it depends. At the moment, we are using Itzinga because we have it for a very long time. We are using Itzinga with Prometheus, and we are using it together, and it works. We are evaluating some other solutions, but well, it works, so we don't touch that. We are in cloud-native world, halfway in cloud-native world. Okay, no offense. It seems you are in halfway in the cloud-native world, since Ansible and other things. Any plans to go all in, using virtual clusters so clients don't have downtimes, you save a lot of resources, and so on? For these customers, we don't plan to go cloud-native. It doesn't. Most of the clusters we are running in this way are on-premise. And for example, if you have a state-owned company or a state institution, they don't have money to buy services like clouds, but they don't have. Every 2 years they have money to just buy hardware. So we are running in this environment. So for these customers, it doesn't make sense to go to cloud or to be cloud native. Okay, next. Would you recommend Minikube for one node cluster? Well, me personally, no. We are running Minikube, but mostly for testing environments, for playgrounds. Because some of our work is research and development, and we would like to test some cool tools, for some cool Kubernetes tools, and then we are running Minikube on our machines, for example, for testing. But I never tried to run Minikube at the production. But if somebody tried, I would like to hear the experiences, really. Catch me in the coffee room or something like that there. So I have no experiences with Minikube in production. What OS you are using? Ubuntu, Debian, Talos? Do you run Kubernetes on bare metal or hypervisor? It depends on the customers. It depends on the customer's environment, because some of the customers are used, or their technicians are used to Ubuntu. So we are using Ubuntu there. Some of the technicians are used to Debian. We are using Debian. Last month we found that we are going to run on Gen 2. Okay, is there a problem? So Rocky, NixOS. I have no experiences with Rocky and NixOS. I have really good experiences with similar setup. We are running on Fedora CoreOS because I like the idea of the self-updating operation systems. But this isn't a single node cluster, because the upgrade process of Fedora CoreOS is rebooting the machine. So we don't run this on single node clusters. But well, we are mostly using Ubuntu Debian for single node clusters. Well, and do you have any critical applications with SLA on a single node? No. Why? Well, usually when if you are in the small IT business, usually client says, well, we can't afford any downtime. And then my question is, well, what's your budget? Because you can run with very small downtimes, but when you ask more and more, and you asked, well, when you have 1 hour downtime, how much money it will cost you? And then I can say, well, when we increase high availability, when we increase the reliability of the deployment, it will cost you that much money. It's a month. Is this when you compare your outage cost with your operations cost? What's your opinion? And that's typical customers. How to say? Customers' choice. What they should do. So we don't have any critical SLA on single node. It doesn't make sense. When you have a critical SLA, you then don't run on single cluster usually. Or you can be Chuck Norris and you can do that. But I have heard that Chuck Norris has more than 100% availability. But okay, and that's all? Great.
Thank you.